Good afternoon. Welcome everybody. My name is Tamas Csonka, and I work as a weather forecaster at Hungarian Meteorological Service. My special area in this field, civil weather forecasting. The first part of this briefing, I will talk about the current weather situation, and we will take an outlook for tomorrow and the vacation time. We will take an outlook for the next couple of weeks, supporting ECMWF weekly anomaly maps, forecast maps. So the second part of this presentation, this briefing, Zsofia will talk about the satellite images, products, and this is the plan. And first part, so this is a convective warm-up situation. This is now over the last 2 hours in Hungary. Mesoscale convective system is forming and traveling from northwest towards Romania and Serbia. And if I am not wrong, in this moment, this MCS is the strongest convective system in Europe. Okay, this back to the one of the most important and hardest question is where you are listening and watching this briefing. Please put your answers onto the map. Use the pencil or any other marker. And make a comment on the actual weather. We are looking for the most exciting weather at the moment. In Budapest, the weather is sunny, some cumulus, some cirrus clouds. It was a shower in the late morning hours, and it's 25 degrees. Okay, everybody is okay. Thank you very much. On our first slide, you can see a natural RGB image from 6 UTC in this morning. And the question is, please mark the area of the precipitation area. So what do you think? Where is the precipitation from these clouds? We are waiting. Okay. The other. Okay. Great. Anybody? Okay, before we check it, where can the high and low pressure system be located? So please draw lines where you think here is, for example, H and L. You can use the tools, the letters. Or you can draw lines, H and L. I see 2 high and the C, other L low and the low here to the British Isles, okay, the other okay, over the Scandinavian and the Baltic Sea, and the other eye over Western Mediterranean, okay, okay. Thank you. I'll try to clear. Okay, and let's check. Okay, now we show you the AirMass RGB satellite image overlaid with open radar fields, and you can see this area, the precipitation area, and some light rain or moderate or heavy rain over Scandinavia and the Baltic Sea, and the British Isles is affected by rain, and some here and there maybe. I try to show convective precipitation over Hungary in the morning hours. Okay. It was good answers. It were good answers. The next slide is the infrared images 10.8 and sea level pressure from the ECMWF model. We can see a low pressure, a cyclone is swirling over Scandinavia and the Baltic Sea. I try to show. Here, and it was good. The high pressure dominates over most of Central and Western Europe, and the cyclonic field is present over British Isles and northwestern parts of Euro-Atlantic region. Okay. The next satellite image is water vapor 6.2 and 3 hectopascal geopotential and wind fields. We can see a strong jet over northern part of Europe, and other one is stretching from the oceans towards Central and Eastern Europe. Okay. The next is the 500 hectopascal geopotential and infrared images. We can see a vortex or a cyclone. As mentioned, over the Baltic Sea and the Scandinavian regions, and its graph is, I try to draw. The graph is approaching the British Isles. It's a short wave graph. It will affect in the next couple of days this region, Italy, Central Europe, and Balkans weather. We will back for that, and you can see thunderstorm clouds over northern part of Italy and we take a look, short animation from the last night. This will be the next slide. Okay, we will show the end of this presentation. We will show the animation. Okay, the next game or question is a game of fronts. This is the name. We can see an RGB air mass image and the pseudo-equivalent potential temperature from the ECMWF model. The question is where could be the fronts, frontal zones, what do you think? And please draw a line. For example, blue line is a cold front, a warm front red, and the occlusion purple. So, and we will check it. Where could be the front in this region? Okay, an occlusion and a cold front I can see at the moment. Huge or big cold front in the Central Europe. Okay, the other, any front, okay, warm front over the Alps or southern Germany. Okay, any front could be there. Okay. A few seconds, I am waiting a few seconds. Any further fronts? No? Okay. Here is the solution. And firstly, UK Met Office analysis chart. So we can see a long curved front in this chart. I try to show. So this is, and it's a tricky frontal zone over the British side, and it's a long waving frontal boundary over most of Central Europe and Western Europe. And the other office is the DVD chart. It's a similar but a bit simple than the previous one. So you can see a long frontal zone over Europe is stretching from eastern part of Europe across Central Europe towards to the ocean. Towards to the ocean. It's a quasi-stationary frontal zone, and last one, the Hungarian meteorological chart, similar, and the previous, and lots of fronts we can see over the British side, and the waving frontal system is frontal zone can be seen over most part of Europe. Okay, and the next slide is temperature fields at 850 hectopascal. We can see Arctic cool air Oh, sorry. Oh. Sorry for that. Okay, thanks. So Arctic cool air is streaming to the east, and subtropical air mass is present over Mediterranean regions, and we can see the frontal boundary in this region. And the next slide is a temperature and gale potential and wind field at 500 hectopascal, and then Thursday 12 UTC, and we can see a trough here, and cyclonic vortex as mentioned, and I will talk about this trough is advecting and traveling to the southeast Europe in the next couple of days. It's next over Germany and France. And next slide. Next slide is Saturday, and the slide shows a small scale cutoff low here over Balkans and Central Europe. That cutoff low is developing over this region. This cutoff low will determine the weather in the next couple of days in this region, and it's a very interesting weather situation will be in this area. So before the trough, very moist air is advecting to this region. We can see the specific humidity more than 10 or 11 grams per kilogram. So this is a region, and the main threat should be the excessive precipitation in this situation, and we can see that forming a shallow cyclone as well in this area. The next slide shows this air mass will be unstable, and vertical wind shear is considerable up to 15 or 20 meters per second. Multicells or supercells should develop in this environment, and some mesoscale convective system is predicted by the numerical models in this region the next tomorrow and Saturday. The next slide is the accumulated precipitation forecasted by other different models, for example, ACMWF, DVD, GFS, Aladdin, AROM, and ensemble prediction system. So you can see a lot of huge amount of excessive precipitation in this region, Northern Italy, Balkans, and western parts of Hungary. Some places up to more than 100 millimeters or 150 millimeters. It's a huge amount of precipitation. The main threat is the excessive convective precipitation, and the other, as mentioned, large hail and convective shear wind dust. So it's a really interesting weather situation in the next couple of days in this region. So take a look at the warnings, meteorology and Zsofia. This is for not today, for tomorrow, Friday. For example, North Italy warning for severe thunderstorm and excessive precipitation, and Croatia, Austria and Hungary as well. And the Zsofia team is issued 1 or 2 levels in this highlighted area. Okay, and it's vacation time. We take a short look the next week. It's a weekly temperature anomaly for 2 weeks, next weeks, and the other weeks, beginning of August. You can see up temperature anomaly and precipitation weekly anomaly. You can see the below the normal northern part of Europe, except far north. It's above the normal, and above the normal most of Mediterranean region, and the precipitation could be above the normal most of northern part and below the normal Mediterranean region, and it's similar the next week as well. Okay, and this is the end. Many thanks for your attention, and the next part, Zsofia will talk about satellite images and satellite products.
I hope you can hear me. Can you hear me well?
Yes, we can hear you.
Okay, good. I will try to speed things up a little bit. So my name is Zsofia Kocsis, and I'm from the Hungarian Met Service. I work with satellite images. So to be true, there has been a lot of interesting features going on in the last 1 or 2 months, so it was hard to choose something. So here specifically, I would like to show you the dust RGB from June. This is an animation over 20 or so days. So we can see the dust storm developing in Africa, and then the dust was transported all the way to the Caribbean. If you can follow, there is a very nice case study on the EUMeTrain web page. I encourage you to visit them. So as Tamas has mentioned, we are in the middle of the convective season, so I decided to focus on storms. So my first question for you would be that which storm-related features can be observed in satellite imagery? There are some possible answers here, so I would like you to take a tick or a minus sign which you think can be observed from satellite, and then a minus sign to the ones which cannot be observed on the satellite images. Very good. We have some on overshooting tops and gravity waves, outflow boundary, Okay, here we have on everything. Okay, I see some X on Hukahu, and we have some positive feedback on all the others. So to speed things up, hoop echo and bow echo are typical radar phenomena. This can be observed on radar. We can see overshooting tops, gravity waves, above Anvil Cirrus plumes, and also outflow boundary can be seen on both satellites and radar images. So the next question is, why are we interested in this phenomena? There are some possibility here, which you can put a plus sign, which you think is the reason we are interested in this. Okay, good. Good. Very good. Yes, they are nice to look at. I like the animation when we see the storm top is boiling. Yes, they are related to updraft and they can be related to storm severity. Very nice. Very good. We will see a couple of sandwich images in the next few minutes. So just briefly, if you don't know, the sandwich image is a visible image where you can see the cloud structure, the top of the cloud, the structure on the top of the cloud, and we put also the infrared brightness temperature on that, so you can also see the part where the cloud is formed and where it's cold. There is a very good product tutorial on the EUMeTrain webpage, so if you are interested in more detail, please look at it. So here, while you are trying to put your marks on the overshooting tops, I will just tell you, or you have already probably guessed, that this is a storm system from the US from last Friday, and they are in very good situation as they already have the new generation of satellites. This is a GOES-R image. The visible image is at 500 meter, the resolution, and the infrared is 2 kilometers. So these images are very nicely, and they have also good temporal resolution. But just you can image that we will have something similar with the MTG rapid scan service in some years, probably in 5 years. So good. Good, you have marked most of the OTs. Very nice. So here you can mark the gravity waves if you can try to mark the gravity waves. Yeah. Also, maybe you can find some others. You probably know the overshooting tops are the most intense part of the updraft. We have the most intense updraft there, where also this updraft reaches or punctures the tropopause and reaches the stratosphere. And when that happens, then we can have some exciting features such as gravity waves or plumes. Very good, very nice. Yes. Good. And on the next image, I would like you to mark the plumes. If you can see any plume on this image. Okay. Anywhere else? Okay, I will just clear this image now, and I will try to show you one of the biggest plumes on this image, and I will also clear again so you can see it. Maybe you can also see my mouse, I don't know, but here is a very big plume. And now, if you allow me to just go over a couple of more minutes, then I can talk about a little bit about these above Anvil cirrus plumes, AACPs. These usually, as the name tells, it's a cirrus cloud above the Anvil, typically vertically spread from the Anvil. It forms when the intense updraft punctures the topopause and drags cloud tops up into the stratosphere. And here, this powerful updraft and the stratospheric jet stream collide, and this collision transports the cirrus cloud ice downstream from the plume. And this is also the reason, or this also promotes gravity wave breaking on the top of the cloud. The plumes are typically warmer than the underlying Anvil cloud because they mix with the air in the stratosphere. So why are we interested in these plumes? A US research by Chris Betka and his colleagues showed that 73% of significant severe weather reports were produced by AACP clouds. They studied over 4,000 clouds or storms. So 59% of the AACP storms generated some form of severe weather. 88% of the storms producing significant haze was associated with AACP storms. And also it's very interesting that 75% of the supercells produced an AACP over its existence. So you have to bear in mind that they have 1 minute or 30-second imagery. So these are essential to observe in detail this phenomena. So here we can have a 10-minute animation of this cloud system, which I think it's very nice, and we can see all the plumes forming, the gravity wave breaking from the overshooting tops. It is a very nice storm. If you are interested, you can visit this page where you can have a look at the 1-minute animation and also some more detail. You will see that in 1 minute you will see a lot more phenomena than you see in a 10-minute image. So here we have another, I don't know if maybe we do not have any more time because it's already 5 minutes after 30. So here is another animation of a Hungarian storm system from June, which caused a lot of damage in Budapest. You can see some place here. And we had a very nice overpass of the polar satellites with fierce imagery. This has 37.5 meter resolution in the visible and 7050 in the infrared. So we can see nicely if I try, you can see nicely all the features, the ring, the cold ring, we can see the overshooting tops, and also we can see here a small plume. In the next image, this is compared with the MSG image, and here we see also the plume at the same time. So this is what I would like to say for now. I hope you could see a little bit what will be available for us in the future, but we still have to wait a little bit for that. So thank you very much, and we are ready to have some questions if you have